What you see on the screen are some sketches that can be found in the sketchbooks of the Renaissance genius Leonardo da Vinci. As you know, Leonardo dedicated a lot of his time to the study of the human body, especially the heart. Quoting him, "The heart is a magnificent instrument invented by the Supreme Master." In this way, the drawings of the artist defied the Galenic vision and set the basis for the development of modern concepts, such as the heart pump, the pulmonary and systemic circulation, the coronary circulation, the valve functioning, or the arterial disease. As you see, painting was the only cardiac image technique available in ancient times, and in spite of how much the world has changed since, we, present cardiologists, keep drawing hearts. Hello, welcome to Cardio Flash College, a place to learn cardiology with flash animations. As you know, in this channel we try to represent with drawings the complex and fascinating world of the cardiology, with the objective to ease the process of academic formation. However, we are not the first to do it, because the heart has been the object of study and devotion since the beginning of time. The visual perception of its beats and its unremovable connection with emotions have motivated the interest of an uncountable amount of people to unravel its mysteries and immortalize in an image its functioning. This is why these are 5 images. Amyloidosis. Number 1. The amyloidosis constitutes a deposit disease produced by the accumulation of an extracellular protein called amyloid. This generates a multi-organ damage of structural and functional characteristics that can often affect the heart. Thereby, the most frequent electrocardiographic finding in the case of a cardiac amyloidosis is the pseudo-infarct pattern and the atrial fibrillation, although the presence of microvoltage in precordial and limb leads are very distinctive. Number 2. The echocardiography constitutes the cornerstone of the initial diagnosis. Nevertheless, no finding is specific. Depending on the grade of affectation, we can find asymmetric left ventricular hypertrophy with granular appearance, right ventricular hypertrophy by atrial dilation, mild pericardial effusion, thickening of the valves, and thickening of the interatrial septum. By its own part, regional strain is a technique very helpful for the early diagnosis of cardiac amyloidosis, because longitudinal strain is decreased in basal segments and conserved in the apex, giving a typical image of Japan flag, easily identifiable in the bullseye plot. Number 3. The cardiac MRI provides anatomical, structural, and functional information of the heart. This allows to characterize the tissue composition of the myocardium and to define the hypertrophy pattern. Thus, the most frequent hypertrophy pattern in the amyloidosis is the asymmetric and not the concentric one. Moreover, a pattern of global subendocardial late enhancement is very characteristic of cardiac amyloidosis, but it is only present in a fourth part of the patients. Being able to find other patterns such as the transmural or the patchy patterns. Finally, some less specific but very suggestive findings are the biventricular hypertrophy, the thickening of the lower interatrial septum, the biatrial dilation, and the mild pericardial effusion. Number 4. More than 30 different proteins have been associated with amyloidosis. However, just 5 of them can significantly deposit in the heart. This way, more than 95% of cases of cardiac amyloidosis are produced by the deposit of the immunoglobulin light chains or by the deposit of transthyretin. In this way, 99-metastable technetium DPD scintigraphy is able to identify those patients with cardiac amyloidosis due to transthyretin deposition, which results helpful in the differential diagnosis of this entity, because depending on the type of amyloid, there are prognostic and therapeutic implications. Number 5. The definite diagnosis of cardiac amyloidosis is based on the heart biopsy. However, if this cannot be performed, it would be enough to identify structural and functional changes of the heart in patients diagnosed of amyloidosis via biopsies performed in other tissues. So, the conduction of an aspiration biopsy of subcutaneous abdominal fat is the most profitable one. The typical image is an apple green birefringence that appears when the tissue sample, previously stained with Congo red, is studied via a polarized light microscope. As you see, hard image can be helpful in the study of the cardiac amyloidosis, and although we would love to deepen even more on this topic, it is not possible because our time is over. It has been all for today in Cardio Flash College. We hope you liked the video. If so, subscribe to the channel and leave a like. We'll see you in the next class. And remember, don't come late. Bye!